Now, but K0 sine theta theta I or theta 0 if I plot this on Kx and Ky in two-dimensional case, as you just mentioned, K0 sine theta is the projection of this wave number, and I draw a circle over here. And that means this length has to be same as what? This wave number vector, that is the wave number on medium 1. This is wave number on medium 0. Therefore, this is theta t. Okay? Okay? It's an interesting graph. Okay, if you prefer, maybe we would write this is theta r, that is equal to theta 0 and theta t. Okay, this magnitude of this wave number is omega over C0, and this is omega over C1. If C1 is small compared with C0, then we will have opposite type of graph. This is the case when C1 is larger than C0. That means I am sending my boys from air to water. Yeah? Air C0 is small compared with C1 in water. So I have a bigger wave number circle over here on left hand side and a small wave number circle over here. Sung-Han? Yeah? Okay, then it's interesting. What if I have angle of incidence greater than this? Then I have trace wave number that is bigger than this, right? And there's no way to match this trace wave number using this wave number. Okay? This is called critical angle. On critical angle, transmission occurs in this direction. In other words, on critical angle, when I shout, transmission occurs in y direction only, right? So what happened in water? There is a plane wave propagating in this direction. Wow. Right? Okay? Okay? If you have the same physics when you handle this structure, that means in a certain angle, the plate propagate in y direction. Okay? That kind of physical phenomena can be used to design or invent some interesting sensor. Maybe. But what if theta r is bigger than theta critical? Then theta t cannot be only real, but theta t has to be written theta something, theta t real plus, in fact, minus j beta. Meaning that the only way to have this relation to be satisfied is by allowing theta t has imaginary part. Why? That will be a good question. I mean, you have to think about. But if there is minus j beta, what happens? Then this means that I have a wave that is propagating in y direction, but it is exponentially decay in x direction. So when I have incident to wave, angle of incidence is greater than the critical angle, then what happens? The wave is propagating in y direction, but exponentially decay in x direction. So what essentially happens is, when I shout outside in certain angle, then I can generate a surface wave. How can you use that kind of interesting physical phenomena in practice? Maybe you can think that maybe I can invent some coating. Maybe I make some coating in the room, and that coating absorbs all the sound energy because it propagates in x direction, and the waves is exponentially decay, propagating in y direction, and the waves is decaying in x direction. That we call evanescent wave. In this region, we have evanescent wave, in other words, exponentially decaying wave. 태용? 이태용? You understand? Okay, those only obtained by exploring the Snell's law in the wave number domain. That was not possible when we were in elementary school. Because in elementary school, if teacher said, hey, exponential decaying or imaginary part, then is he crazy, right? But now we know the meaning of exponential decaying and complex function and imaginary part. Okay, that is possible. Okay, the other one. Critical angle. 임계. Sure.